All right, we're going to be going through the elimination method today. So you guys have been exposed to how to find the solution to a system of equations by graphing. And so what we realized is when we have two linear equations, two lines, graphed on a coordinate plane, that its solution can be found by where they intersect. And we do understand, too, that sometimes lines do not intersect, and those give us special solutions. But what we've been looking at is two lines that intersect at a certain point, and we identify that that is the point at which works for both. Therefore, it would satisfy both of the equations. Today we're going to go through a different method, because as you guys can realize that sometimes our intersection point is not easily found. Yeah, we can see two lines intersect, but can we actually quantify that? Because it intersects, it may be in the middle of a box, and so is that a half? Is that 3/4? Is there a way to exactly quantify that intersection point? And so we have basically an arithmetic way of calculating that intersection point. And we call that, one of the methods is called the elimination method. All right, so here's an example. So we have a system of equations, 6x minus 5y equals 21. And we have a second linear equation, 2x plus 5y equals negative 5. Sorry. All right. So what mathematicians found is that if we could take these two equations and add or subtract them together, we can use this to isolate one of the variables. And what I mean by that, and you guys know what isolation means, is to get a variable by itself and find its solution. If you guys notice here, and I'm going to highlight, look at our y term, negative 5y and positive 5y. See, if I combined these two equations, okay, with addition, do you notice that negative 5 and 5, that's 0. So basically, so think about this, this eliminates the y term, hence the term elimination. And then we combine the x's, we get 8x equals 21 plus negative 5 is 16, right? And so then we just solve for x. So the idea is, conceptually, if you understand this, we want to eliminate one of the variables so we can solve for the other. What makes this difficult in finding the solution is we have two different variables, so how do we isolate one of them? Do you know what I'm saying? So this way, it eliminates one of the variables, and so we can concentrate just on x or just on y. All right? So now we want to get x by itself. We're going to divide both sides by 8. This very simple equation. We get 2. So what this is telling me is that these two lines, okay, these two equations, right, are the same when x is 2. Okay, and that's the x value, right? Now, what's the y value to our intersection point? Well, what we simply do is we take this 2, which is the value of x, and we can substitute it into either one of these equations. Now, when looking at the two equations, 6x minus 5y equals 21 and 2x plus 5y equals negative 5, I'm thinking the second one might be easier to substitute in for. Now, some of you might be thinking, why can we plug into either? Now, think about it. This is where they're both the same. So if you think about it, this value for 2, this x value of 2, will work for both of these equations because that is where these are going to intersect. They're going to intersect when x is 2. So it doesn't matter which one because each of them will give us the same y value. So I'm going to copy the rest of the equation. And now this becomes a simple equation to solve. Okay. We're going to subtract the 4 from both sides to isolate y. Negative 5 minus 4 is negative 9. And even though 5 and negative 9 are not compatible, so I can divide evenly, that's okay. We're going to divide both sides by 5. Or you can multiply by the reciprocal 1/5. And so y equals negative 9/5. We could just leave it just like that. Some of you would prefer probably to make this a mixed number, which is negative 1 and 4/5. Okay, and so this is our solution. We call this elimination method because it eliminates one of the variables. Now, I want you to pay close attention to our solution here. Okay? You notice this, what this is telling me is that these two lines are going to intersect at 2, -1 and 4/5. Do you notice that if we try to graph this to get the answer, that we are probably not going to see these two lines intersect exactly at -1 and 4/5? How would you actually calculate that if you saw that on a graph? Okay, we probably wouldn't. We'd probably just be able to estimate it. So it's imperative that we have a different method to exactly calculate the intersection point. And so that's where this method comes in handy. Okay, so the solution to this system is 2, -1 and 4/5. And that is what we would see if we graph this. They would intersect at 2 and -1 and 4/5. All right, I hope this helps you. Thank you.